Yeah, I think I'm audible. How to why did they started in studio? How could I say live chat? Okay. Okay. This stream is about how search engines works. So basically search engines are um like search engine is something that you ask something and you get something in return. Maybe as the links of some website or something like that. Yeah, Google is one of the famous search engine that everyone knows. And apart from that, there is a famous tool that uh, runs the search engine called as Elasticsearch. The Elastic.co organization owns it. And yeah, let's see today how it works. So I'm sharing my screen. Okay. Let's create a one folder, right? I can name it as streams. And inside this, we can create November 25, 2025. Let me open this here. Let's create a file called as search engines txt. So basically, this is the template that I use to prove some of the mathematical stuff for some of the DSA problems. So this is not useful for us now. So the idea is to see how search engines work. So like what actually you're searching. So let's say assume there is a box um, which stores the data that data is like can be anything, right? Box stores the data. And as a user you want to search for something and uh, oh, this is pretty intelligent. Wait, is it taking my voice as well? Okay. So based on the user will give a search query, and the idea is this box is in search query is input, and box should return relevant data from user query. So for example, if I go to Google and if I ask Euclid theorem, uh, ignoring this is the first document, this is the first website link I got, and this is the second thing I got, and so on. You'll be getting results for your key. So yeah, we'll see now how this works, how actually this works internally, how search engines are able to do this. Usually in search engines, I mean the box, like we'll be referring search engine as a box as of now. The data will be present in documents. Document is not a PDF or something. It's like a group of words which form some lines, maybe a paragraph. So let's say I'll show you something. Okay. So let's ask Gemini key. I want some documents so that I can explain how search will work over those documents. Keep it maybe which domain you want to keep. Okay, coffee related, and also give sample query where two documents are relevant and should be given as search results when queried. I just want to show with a small example how actually this search things work. So so you can assume that um, this document can be like, let's say, call it as chunk or document itself. So this is list of documents. This is a list of documents, right? And from the available list of documents, you need to fetch some documents which are relevant to user query. Let's see if it generated or not. Yes, I think it generated. Okay. Okay. Let's see this. Okay. Just to make our life easier, I'm just making it to. Oh, where did it go? Okay, sorry. Okay. Mm, these are the three documents that we have. Um, the ID1, ID2. Okay, let me remove this so it doesn't. Say there are these three documents in the box, and when user query is like this. User queries. What is the user query? The Gemini gave espresso milk. User queries espresso milk. Let's keep this in a double quote. So now what you expect is you expect as a user. I expect that whatever the answer that I'll be getting, it should contain words this. Otherwise, it will be irrelevant, right? Because like what's up? You're asking espresso milk, and um, I'm returning regarding uh, chocolate ice cream. Doesn't matter, right? Because I queried for espresso milk, and I expect the information for the espresso milk. For this, what you need to do, what we can do, what comes to my brain is like step one. Uh, for each word in user query, search in entire list. If search entire list of documents, if any documents has either of the words, either of words, um, say espresso or milk, add the documents id to the answer list, so that we can show this list to the users. In the step 2, how we can do the searches. um, Tokenize the, sorry, tokenize again is a um, it's a kind of misleading word, because tokenization you might have heard in LLMs. So break, okay. How search ideally should happens is, in each document in the box and each word in the document, see if user query word is present or not. For this we need to iterate from every word. For this we need to iterate from every word in the document. Iterate through, yeah, iterate through every word in the document. Yeah, again it's the same thing. If user query is present, add it to the answer list. So what is the, okay, now if you see, espresso is present in doc id. If I click on espresso, double click, it's highlighting the text from id1 and id2. So espresso is present in doc id 1, 2. Milk is present in doc id. Where is this? Where's the user query? Whereas milk is present only in 2. 1 doesn't have milk. So milk is present in doc id 2. Now if I now if the union should happen, because user doesn't want to see only this, user doesn't want to see only this. The best chunk is the second chunk. Okay. The best and most relevant chunk document is with id 2. The reason is simple, because it's not both, all user query words are present in this document. It's not, I'm not here again, I'm not telling that second is not answer, first id is not, document with id1 is not an answer. It's also answer, but it's less relevant. id1 document is also an answer, but less relevant than id2. Okay. Now let's see how complicated this search. If you want to do this programmatically, TC. Like I love calculating the time complexities. Yeah, for some expected, except for some graph problems. So now let's assume there are m words in user query and n documents in the box, and each document has average of p words. How to, okay, p words, and each word is of average length, say q characters. Okay, let's not go too much lengthy in each line so that to scroll attention span will go. Yeah. Now the time complexity will be um yeah, obviously like product of each m into n into p into q, because for every user query and for every document and for every word you are checking all the characters if it is matching or not. uh, Definitely, like, imagine how slow is this process. How slow is this if box has more documents and user query is long. Correct, nice suggestion by uh, alphabet, not alphabet, anti-gravity. User query is long, and yeah, again, like, again, you can make words for each factor of this. Each document has more words and each word is more long, something like that. But yeah, the whole point is this is too slow, and this is a very naive search. And in order to imagine how slow this can be, imagine the internet data. So let's say, for example, here I have searched Euclid distance. So you can imagine how many yeah, Euclid theorem, let's say. You can imagine how many articles or websites or whatever on the internet will be showcasing the Euclid theorems for different purposes, right? So in order to search for in every of this resource, here if you can see, and the search time is like fraction of seconds. My first result is this, and second result is this, second most relevant result is this. How does this happen so fast? If the current logic is this, where you are doing all this linearity stuff, this wouldn't have been this much faster. uh, how to make this faster? Nothing I'm inventing here. It's already it's already done, because if I invent this thing, I would not be here. So yeah, it's already pre-done, and there is a data structure that most of the search engines, by the term most means most, like 99%, even like maybe every search engine that most search engines use is yes, AI is so smart, man. This auto completion is so cool. Inverted index. And what is this inverted index? uh, so usually what happens in the book index, normal, you have a book and you have index. What happens there? So if you want some information, you search in that index, you will find a page number um, where that info might be residing. Just reverse this, the entire thing that I have shown, that I have told you. So you have the documents where these are present, and you actually know before only in which page this is present without searching itself, before searching. So that is why this the no, this is a normal index, this is a normal index, and that's why it got the name as inverted index, because it works in the reverse how the usual index works in real world. So let's see how does this inverted index works. In simple terms, inverted index is nothing but a map. Yeah, map of maybe string comma list of integers. Okay, Java, yeah, Java is so good. Yeah, maybe it's a map of string of list comma integers, and we'll see what is this what is this map, what is the string, and what is the integers, and why we have to do that. So imagine, instead of searching, uh, where is our example? Yeah. Instead of searching espresso for each ID and each word, you somehow know before that. Let's say, imagine somehow you know that espresso is present in documents 1 and 2. Also imagine somehow you know that milk is present in documents 2. Yeah, AI made a mistake here because 1 and 2 came, and so it's told 2 and 3 just to follow the uh, rhythm, but in 3 there is no milk. So yeah, coming to the point, um, in the document 2, so if you already know this, and I think the problem is already solved here, right? Because you won't, since you are, for what you did search, the searching for what you did, searching in the entire document, entire words you did because you want to see in which documents it is present, and I am telling you that espresso is present in documents 1 and 2. So you'll be like, yeah, search is skipped, so the entire m into n into p into q is gone. And same with the document 2. I was telling you that, hey, milk word is there only in document 2. What I will do is I'll just simply add that 2 into my result in order to show you that document. So how is this possible? Simple, right? So there is, in order to tell what word appeared in which document, you must pre-process the documents, so that to create the inverted index. I will explain you with the code as well how to, with the small demonstration, how does this happen. And I want to tell you something. Okay, say I'm telling that, okay, I'm telling for each word in document, add it to inverted index, and add it to add it as a key. Let me make key capital in inverted index. For each word in document, add it as a key in inverted index, and its associated value is, what is its associated value of that word? Obviously, list of documents in which it appeared, in which all this present. So yeah, one more thing, you can ask like, hey, but so let's say there are what, like listen, listens, listening, and yeah, maybe one more form of that are present in the same thing. We cannot keep increasing the keys of the map so that to accommodate every tense of the word, something like that. So okay, let me put it out in a text format. What if there are terms like crash, crashed, crashes, crashing? So yeah, as of now I just got these crash words in my mind. So yeah, I think this list might be big. So yeah, so what if there are words like this in the document? This unnecessarily adds the complexity of the duplication, because in most of the cases, not in most of the case, all this will mean the same thing in terms of meaning. All this matters the same, doesn't contribute, all each of this word contribute same to the answer, same to the document, or same to the answer for the user. So what pre-processing should be done is, um, pre-process each document to and store only a stem root word as key in inverted index. So for the words like crash, crashing, and crashed, for all these words, right? The root word is, yes, crash. And you can just imagine how much uh, level of this thing I'm getting, how much um, extra computation we are skipping. One thing is, by this, our map, our inverted index size is not unlimited. It's comparatively less because we are skipping so many things, right? By taking the root words, comparatively less. Okay, some changes. Okay, it's comparatively less. And yeah, i I think, yeah, um this is the conceptual thing that I can show here. Now I wanted to show uh now I wanted to show a live code example that I have done. Okay, small projects, search engine, mm, not an text implementation data UVM. Yeah. So okay, let me show you the documents also that I have taken. Open corpus document.py. So yeah, this is the documents that I have taken to just show the reference of how inverted index should be implemented. So if you see, this is a very simple document, right? In general case, you will have different attributes or fields for each document. Because for simplicity, I just added what matter to us is ID, title, and text. I'll also tell why title and text I have written. I have given why not only text. Yeah, this has some 11 documents starting from 0 to 10, and yeah, pretty big documents. And there are this again. These documents have been generated from Gemini, saying that okay, I need to build an inverted index. So I want data such that I can best get the understanding of how inverted index works. So if you see this function, I'm importing the documents from this document.py file, and you need to tokenize the documents, and you need to store, like you need to for each document you need to see what is the token and what is the doc ID of that. Uh, so if you see, okay, sorry. Yeah. So if you see, tokenized document is a list, and here I'm using one of the library for stemming in the sense it removes the extra things at the last, and it preserves the root word. As I told, if you apply stemmer to these words, what is this word? Yeah, crash, crashed, crashes, and crashing, you will get the root word as crash. Or you might, yeah, you will get the root word or crash, or it might be different. It doesn't matter, right? I'll tell you why it doesn't matter. So for replacement, your document might have the hyphen symbol, and I'm replacing with white space. It might have underscore, I'm replacing with this. Again, you might have so many delimiters, maybe comma, and this symbol, apostrophe symbol, like the quote, single quote symbol, something like that. But for simplicity, I've just taken these two. And for the cleaning purpose, I have converted into lowercase because data might be present in mixture of lower and uppercase. And I'm splitting each document with a word. So machine learning is a field will be each word is the list of tokens, and each token I'm stemming it using this stem method, or yeah, because um, learning will reduce to learns, learning and learns will reduce to learn, um, and crashes crashed and crashing will be reduced to crash. Yeah, so the final token will be oh, so yeah, so let's say, and this has the WH words. Stop words something in search matters was the words which doesn't contribute to the result. Is, a, of, that, this, the, to, what, WH words. There are some common stop words which doesn't contribute to any of the results, and all of these I have made as a list, like WH words. You can see all these are like normal common words. Doesn't contribute to any of the things. And yeah, we are also improving in this case. Why stop words uh, can uh, can improve a little bit faster. I'll tell you. Um, so yeah, after processing, our document ID 0 has these as a tokens, list of tokens. You can see, and output of this is a list of tuples of um, the tokens and its respective document. Now, yeah, now we have the document ID and list of tokens present in the document. We need to iterate over this result to build inverted index. And inverted index is dictionary of string and list. Uh, yeah, you can use string and list of integers. So it takes a so yeah it takes the this output as a input for this model tokenized documents, and it returns the inverted index. This is the inverted index, and the list of in why am I going with set instead of list? Because what if no the string will be the this thing, right? But what if there is a word machine appears more than two times in this? So in that case, the inverted index might looks like this. So the word machine, and it's presented in the document list 0 comma 0 comma 0, because that's what our current logic is doing. If this is a list, in case if this is a set, it happens only once. uh, okay, let me type this 0 if we use list, which is inefficient, right? Because we don't want unnecessarily to store the duplicate, and it doesn't actually matter how many times machine is appearing. Yeah, I'll again come back at this and correct it. Yeah, but for storing it doesn't matter. Now let's say if I, instead of making this as a list, if I made it as a set, now machine word will have value of only 0 ones, and this is what we want. Okay, now let's go back to our this. mm, yeah, for token and document ID in document docs, these are the list of tokens, and this is document ID it is talking about in the tokenized docs. And for each token in the tokens matlab this list, we are adding the token as a key and adding the doc ID in which it's 0. So for machine 0, learn 0, field 0, like that. If machine is present here, it might be present, but yeah, then it goes to machine and it will be 4, 0 comma 4. And if machine is present in 5, it will be machine 0 comma 4 comma 5. That is how inverted index was built. And here I'm printing out the inverted index to just show you an example. Abil token is present at in the document 0. So abil is basically the stemmed word of the root word of ability, and aiming the aim is the root word of aiming, and it's present in document 2. Algorithm is present in the document 0 and 2. As you can see here, um, yeah, algorithm is present here. And if I double click on this, it should highlight somewhere downside also. So it's not, but it's present because program can code never be wrong. So yeah, if you see there are, this is a pretty big inverted index. If you see, it's not that big, but yeah, it's big compared to uh, yeah, the data which we have. Now we have inverted index. How do I query it? Let me add a small. I can add this to show example. Say my inverted index is this. Okay, maybe this might be root word for continuation, continuity, or continuing, or continuing, something like this. Maybe this might be the continuous, sorry, continuous. This continue is might be the root word for all of these words. uh, Not sure whether this word present in the actual data or not, but yeah. Now say user query is what is cumulative continuity. So this is the user query. Now you cannot tell that, like, okay, let's search for what in this, what is not present. Okay, go to is not present, go to cumulative, it's not present, go to continuity, it's not present as a key in this inverted index. You're wrong, because first of all, whatever, this is a golden rule, right? So this is what I follow in my at my work also. And I think this is pretty common and everyone also aware of it, but it's just it's the most important thing. Whatever operations or processing is being done on data while storing, same operations and processing should happen on user query as well. This I read in one of the Medium article, and this is so much powerful, guys. Once I explain proof, not a proof. Once I show the example of why this should happen, I will tell you why is this. You will realize why is it so powerful. So we did two things in while pre-processing. While pre-processing, one, sorry, one, eliminated stop words. Two is stemmed the actual words into root words using Porter Stemmer library. And I'll also tell why this should also be common for both pre-processing while ingestion and in the retrieval side also. Say now if you don't do any of these things, and if you start seeing in the map dot get, it doesn't give you a result. The result is empty. Yeah, the result is empty, and user will be frustrated. User will be like, my data is not available in the inverted index. User will be frustrated. Now what we have to do is simple. Do same things on user query, simple as well. First, eliminate stop words, stem the actual words into this. uh, Tokens from user query. Let's see the list of tokens, right? So what is cumulative continuity? So these are the tokens that I extracted from the user query. And now what I do is, for each token, do these things. One, see if it's in stop words list. List or set? Yeah, it should be set, because big of one lookup. Let me write this also, because of big of one lookup. Now if it's not there in set, okay, if no, skip this, go to next token. Now after doing this, you will end up in the word what is that word? Cumulative. Cumulative is not present in stop word set. So stem it, because we are, before storing the actual data in the box, I mean, like, it's no more a box, it's search engine. You guys are familiar by now. Before storing it in the search engine, we are stemming each a token in the documents. So stem it into root word cumul, and search for cumul in, yes, our inverted index II. Okay, actually it realized that II is inverted index. I don't know why it's not coming again. II. Okay, search on our inverted index. So booyah, it's working. It's there. It's there in the, which document? It's in doc3. Now again, do same thing for continuity. Continuous. So stem it into root word continue and search for continue inverted index. Booyah, it's in doc1. Okay, it's in doc1. Okay, let's we'll talk about it in later streams. Why? Okay, check it. It's in the doc1. Now show user doc1 and doc2 as answer. As okay, let's agent do the task as answer. So yeah, this is how the fast lookup happens in the search indexes. And I cannot tell this exact thing. I'll tell you why it is not exact thing. And I'll also tell, this is the basic implementation of inverted index. Let's me add the basic inverted index is this. And yeah, this is my basic inverted index. And actual real world inverted index for this Elasticsearch engine I have explored internally was, it's it's a little bit more complicated. And yeah, it's not complicated in the sense, not complicated to understand, complicated to implement. And I'll tell you why is it complicated to implement in the next stream. But yeah, this we will stick to this, because I think it's a too much info of this code. Yeah, I'll show you the code also, how we are searching it. So the same thing again, for querying the index, I am doing the same thing whatever I did to the tokenization. So I am making into lower cases, and I am splitting for each token. For each token, I am stemming it, and I'm appending the final query tokens. So these are like Qumi, and this after this line, the the tokens might be continue and cumul. Yeah, and query results will be for each token in this final query tokens. If my token is in inverted index, and for the query result, I'm adding the entire list of whatever the documents it is containing. If it is not, nothing. I'm just giving the empty result. And after getting the query results, if you see my question is where to learn about clustering models. This is my question. So if you see the tokens generated from this are cluster, because clustering has been changed to cluster. Models, root word is model, learn is learn, and yeah, about where and to doesn't matter, doesn't contribute to the answer because those are stop words. And if you see, these are the documents. And yeah, the question is, if there are multiple documents, which one should I show them? Isanaki, I cannot show 0, 1, 2, 3, 4, 5 because it's dumping too much info to the user, and that's a bad practice. Too much search result for a single query is a bad. User might get overwhelmed by the amount of answer he gets. So yeah, and we'll also see in next stream how to limit this. Okay, next stream, um how to limit the number of document to show to the user, how real life inverted index, it's not looks like, it's built like, in terms of accuracy and efficiency. And we'll also discuss about what contributes to what contributes to accuracy and efficiency. I think these are the three things that we'll discuss in the next. We'll discuss in the next thing, next stream. Um, I'll be attaching the link of this Jupyter notebook in the description or in the pinned comment. So please check it out. And yeah, I think I still have some time. So okay, I think I still have some time. So let's solve one lead code question. Which question? Why not today's problem of the day? Okay. Let's open. Let's close this. Yeah, I'll attach both this txt file and this IPY in Jupyter Notebook. Or else I can create a GitHub repo and I'll be pushing this under the streamed folders. Yeah, I think I'll do that. And I'll update in the first comment. Okay. New window. My RAM is not that high, so I'm just closing this window. It's just 24 GB. And folder, which one? I don't know, but yeah, this is the, I think this is the yesterday's question that we did. So much of proofs and stuff. Okay. I think yesterday some people were telling the font is too less. Let me increase it. So what's the question name? Smallest integer divided by k. Mm. Like I don't know whether if it's everyone or it's just me. After reading the title of the question, I somehow, in my back of the mind, I try to frame the question, and yeah, most of the times it matches with the actual question, even without reading the question. Surprisingly, yeah. Let's copy the. Let's copy the method. Okay, it has only k, but smallest integer divisible by k, but smallest integer divisible. Okay, let's see what I am getting by reading this question. Okay, smallest integer divisible by k. Smallest integer divisible by k. Isn't it k? Because k is equal to k, and it's the smallest value that k can divide to remainder 0. But yeah, I think it's a medium tag, not that simple. Let's see the question. What it asked. Given a positive integer, you need to find length of smallest positive integer n, such that n is divisible by k and n only contains the digit 1. Return the length of n. There is no such a return -1. N may not fit in 64-bit signed integer. Okay, looks, the first read it is bit overwhelming. Okay, this is given in the method. You need to find the smallest positive integer n. Length of integer. Okay, you mean to say number of digits. Okay, such that the number n is divisible by k and n only contains digit 1. Oh, okay, number of ones basically. Return length of n such that, okay. This is so obvious, man. I don't know why for some questions examples doesn't help at all. Zero contribution. Okay, k is equal to 2 minus 1. There is no such positive integer n divisible by 2. Okay, let's write down the problem first. Given a number k. Okay, let me make the auto of advanced settings. Let's go to advanced settings. Auto open edited files. Open files in the background image and create them off. Enable agent web tools off. Open agent on reload off. Yeah, we're good now. I think no more disturbance should be there. Bapre. Why is it again coming, man? Okay, let's ignore it. So given a number k, and we need to find smallest length. We need to find, not smallest, minimum number of ones, such that number of ones appended is divisible by k. Okay, for example, take 2. 1 doesn't divide, 11 doesn't divide. Yeah, nothing divides, guys, because the moment they're appending 1, so it's a mistake, because the moment they're appending only 1, it's a mistake, because it's odd number, it makes it odd number. So this also doesn't matter. This example, take 3. 1 doesn't divide, 11 also doesn't divide, triple 1 divides, because sum of 1 is equal to 3. Divides. So answer is triple one. Is it? No, answer is not triple one. Okay, answer is 3 because 3 digits. Answer is 3. Traveling 3. Okay. Okay. Oh, okay. K is huge, guys. K is 10 power 5. Do you have any other questions? No. Okay. Um, how to make 1 to 11? If it is a bit, you can multiply 2 and add 1, but it's the number. Oh, okay. Is it like into 10 plus 1 equal to 11? 11 into 10 plus 1 equal to 311. 311 into 10 plus 1 equal to 4 ones. Okay, and so on. And so on. Okay. Okay, I think I kind of got it. And every time, if you see, so start with one, and for each operation, which is like into 10 plus 1, for each operation we are appending, we are increasing one digit. So after 4 operations, like you might see 3 operations, but assume the initial answer is 1 and number is 1. 1 plus 1 2, 2 plus 1 3, 3 plus 1 4. So if we keep a counter, increment it every operation, and return that counter return. Okay, I think I got it. Babre. And till when we should do it, since they ask minimum, since they are smallest or minimum. Okay, smallest integer, we should do loop till n modulus k not equal to 0. Okay, let's initialize int n equal to 1, counter equal to 1, counter equal to 1, while n modulus k not equal to 0. While n modulus k not equal to 0, now we have n, now we have 1, we need to make it 11, so n equal to n into 10 plus 1. 1 became to counter plus plus, and 10 counter. Is it like okay? 1, when 1 becomes 11, counter will be 2. When 11 becomes 111, counter will be 3. 311 modulo 3 is equal to 0. So this while loop doesn't execute and it comes to here and it times 3. Okay, let's try running this. Oh my god, why is it running too much? Time limit exceeded. Okay. It's the time limit exceeded again. Okay, let's run for 2, right? Okay, because when k is 2, the condition is never met. Condition is never false because it's always not equal to 0. So condition is always true. Both are same. Always true and never false. Yeah, both are same. When k is 2, the condition never falls and never fails, and we'll be keep on implementing. There is no break out of this, so that's why we are not executing here. AR, what is the suggestion, man? If I just only check for k equal to 2, and the next test case will be there'll be so many. Okay, not about k. Okay, if I check for n modulo k here instead of k modulo 2, if I return -1, but n is not limited to 2, right? N is still like k is till 10 power 5. N can be anything. Um. Okay. We have to how to block this. In what case? Okay. Are you guys also observing the thing which I'm observing? So say, hey, where is this man? Okay. Sorry. Hey, what is happening? Okay, I think I just now observed something. Say when k is no need to go to 1,000. So let's say go to 100. So is it like okay? Okay, let's do it here instead of doing it in the code. Let's do it here. Say when k is 100, what actually happens is um you need to start appending ones till like the 100 ones. I mean like this leave about the int even long, and I don't know whether what is the data type which stores more that much number as a number. So how to initialize n? Here itself we are wrong, guys. Here at n equal to 1 itself we are wrong. Int n equal to 1 itself we are wrong. Even if I make it long, which the anti-gravity suggested, then also I think long is like worst case 64 bits, and if 64 bits are set to 1, and still it is less than even if 64 bits are set to 1, what is the maximum value in the long? Assuming it's a 64-bit positive integer, say all bits are set. If all bits are set, it will be 2 power 63 minus 1. Uh, okay, but still, then it's definitely less than um, 10 power 5 digits. That much I can guarantee. I don't know the exact value of 10 power 5 digits. Yeah, doesn't fit there. But so what is okay? Even long cannot hold. How can I declare this? Mm, okay, does modulo anything helps here? So let's say uh, so let's say there are two numbers, and if modulo of that both numbers is same. Okay, if I think we are moving towards something. If we have two numbers A and B, and there is a number C which um, divides, which modulo mean which gives same remainder for both A and B. We have two numbers. Yeah, I think this is so obvious. I don't know why it is giving. Okay. No, anyway, what is actually matters here? What is the important operation that you think is happening here? Is it this, or this is just masking us from looking at the important operation? I think the important operation is here is modulo, because we don't care how many numbers are there, because at the end of the day we are doing it, we are getting the remainder of it when it's divided by k. So it's just a modulo operator. So we can do something. So let's see this example. Let's take n equal to 5, sorry, k equal to 5. So 1 is not divisible, sorry, 1 is not divisible, so doesn't happen. 11 will be divisible. So here how it is happening. 11, 1 into 10 plus 1 is 11, and its modulo is 6. um Now, like, how will you get triple one? So triple one, so 11 into 10 plus 1 equal to triple one, and the remainder is 1. So my, and if you take this triple one and if you keep multiplying with 10, the digits will be getting appended and the problem will never be solved. Now a small observation here that you can get from the modulo operation is, so if it doesn't matter, so what you are getting here is this remainder. This remainder is being compared with 0, whether it's equal to 0 or not. As soon as it's 0, we'll return the counter. In order to get this remainder as 1, you no need to, you no need to just um you no need to um you no need to multiply it with the previous number. You can even, who told it is 6, it's 1. You can even multiply this, instead of multiplying with 11, with this remainder. So even if it is 1 into 10 plus 11, then it's 11, then also remainder is 1. Now again, if you keep this will be going itself. So if you take k equal to 5, and answer will never come. Does k equal to 6 comes? 6, 6, 12, 8, 4, 0. Again 6 is coming. So what is this? Okay, my bad. Okay, so what you can, 6 also it's not possible to show. I just want to see which next bigger number is possible. So in this case, when I'm stuck with inputs, what should I give? I go to discussion. Here, okay, we should see some test cases. There will be some really cool guys who, after submitting the questions or when they stuck with the questions, maybe like wrong answer, they'll upload the test cases here, and that is super helpful. We don't have test cases here. Let's go to second page. Okay. Okay, this doesn't make any sense. Okay, I think, yeah, someone has it. Yes. Uh, let's take sorry. Arey bhai, let's take is copied. N equal to 9. Sorry, k equal to 9. And let's see what is the answer. Okay, 1 1 will be 1. Next, instead of doing this 1 into 10 plus 1, you can do 1 modulo which is same, which will be 11, which will be 11 modulo 2. Why is this coming, man? Now ideally, let's say if you are not taken this 2, and if you taken this 11, 11 into 10 plus 1 will be triple 1. Triple 1 divided by 9. 9 ones are 9, 21, 9 2 is 18. The remainder is 3, I guess. 9, 10, 11, 21, 9 3 is 18, 23. Yeah, 3 is the remainder after multiplying with 11. Let's multiply with 2 and see. So 2 into 10 plus 1. And how much is it? It's 21, and still remainder is 3. So yeah, did you observe something that happened here? So the initial number is triple 1 when mod with 9 gives 3. If you want the same remainder, so subtract max divisible max multiple of 9 from it, which is 90. So if you subtract triple 1 from 90, the answer is 21, and which in turns 21 modulo 9 will be 9 3 is 18 3. So yeah, I think this is a proof, guys. So instead of multiplying with the 11 triple 1 4 ones with into 10 and adding, just this ka modulo do it with k, and uh, for that result you can do it here. So in that case we are not exceeding the limit of long whatever. Yeah, I think that's the very crucial and critical observation. And again, all this discussion, all this proof and observation will only solve one issue. That is um, int overflow, int or long overflow. Int or long overflow, it will do, but we still have how to stop this infinite loop in which answer doesn't exist. Okay, sorry, why did I control Z? Yeah, now here what I can do, it will become 11. 11 modulo will be 11 modulo 3 will be, okay, I just have to add this step. Yeah, I think now okay, let's just iterate, right? Like why to take risk. 11 modulo k will be 11 modulo 3 is 2. So now in this step n will be 2, and 2 modulo 3 is not equal to 0. So 2 into 20 is 2 into 10 is 20, and 21. Okay, modulo 3 equal to 0. So let's take n as 11, right? Because if n is 11, this step will be 11 into 10 triple 1, which modulo 3 is also 0. So I think we are right. Yeah, I think this is the only modulo k we missed. Now the overflow will not happen. Yeah, I think, yeah, one more point is, one thing I usually see is the constraints. So if the constraint is small, if let's say if the constraint is simply like, say, some 20 or 30 k value or 100. If this would be a easy problem, if this is a easy problem, constraint easy tag, sorry, if this would have been easy problem, easy tagged problem, constraint wouldn't have been this much. It might be around 100 k 100. In that case, maybe 50, because k 100 also, if you have k 100 and n value will go to 100 digits, and this is little bit, I don't know whether it's not non-intuitive to come or not, because we have observed, we have done so much of mathematics and some proofs here in order to come to this just one operation addition, one operation add to the code. And yeah, if I think if this is an easy question, the k value might be till 7 or 10 10. I'm guessing it's, if it is 10, we could have simply written one list something like this, saying that these are the possible numbers, because this one size will never grow more than k. Now check, why it doesn't, why the maximum number of digits in this will not grow more than k, because in the question they are the smallest number, so that's the reason. Okay, okay, now we need to fix the second issue, how to stop this. How can I stop? I think, yeah, again the most diverting point in this question is this multiplication. We'll be focused on this multiplication and this operation. The actual game changer of this question, which is playing with us, is this modulo operator. And for me it's a dangerous operator, because there are unlimited number of proofs and mathematical things that you can do with modulo operator. What is the, how we can stop it? Okay, so let's go to two multiples here. 2, 3, 4, 5, 6, 7. Let's go to 8 and also. This remainder is 0. This remainder is 1. Okay. Again, this remainder is 0. Again, I mean to say, uh, these are the uh, possible values of, these are the numbers, normal numbers, and num equal to 2. If you modulo any of this with the num value, what are the possible uh, values present in this array? 0, 5 modulo 2 is 1. Sorry. Yeah, I think it's, you can observe one pattern here. 1, okay. If you take with 3, and if you take 8, 8 modulo 3 is 2. If you increase by 1, it's divisible by 3. So yeah, oh yeah, this is also a good observation. For a num k, for a number, okay, modulo range when any number is divided by k is always, yes, Williams man, is always less than k, not equal to also, because anything modulo 5 cannot be 5, because if it is 5, then 5 divides it. It might be 4. You take, for example, take it 24. 24 modulus 5 is 4. You increase just by 1, 25 will become 25, and which the modulus is 0. So here what we can do, we can declare a set integer new has set, and if we see the num here, That means we are seeing we are seeing the number which gives same remainder again, that goes into cycle. If you see here 0 1, and this series will be repeating, right? 0 1 0 1 0 1 0 1. It doesn't matter what do you think 5 contributes to this answer, because 5 doesn't contribute anything here, right? Because 3 is already showing the module as 1. 5, if 5 also shows as 1, if 3 is useless, 5 is also useless, because the main operator is modular here. So what you can check is here, let me add if set dot contains, because we need to find the n, right? First return -1. Okay, I think this should be fine. Let's submit this code. Okay. Okay, let's run to see if it is passing or not. Yeah, yeah, I think we're good to go to submit. I hope any edge case, since k is 1 and there is no headache of multi. Yes, we got accepted. Oh wait, but 5.45%. Means there is one more optimization here. And what might be the optimization? Okay, what's the time? How much the stream happened? 1 hour 18 minutes. I think yeah, it's not late. Okay. Um, what did we have here? Why is it going like this always? Okay. I wanted these sections to be so distinguishable from each other, so that yeah, this is one of the good observations that we have observed in determining this. And potential improvements. Is anyone there watching our stream, or it's zero? Sad life, zero. But it still doesn't matter who's seen live or not. This I'm just solving for myself. But search engines is an important topic. You guys can go to the recording also. Where we can improve. Asset, how much asset will take? The size of asset max can go up to um okay 10 power 5 minus 1, because the reminders ranges from 0 to k minus 1, correct? We have to eliminate asset. Yeah, if you use array of size k also, then that also agent one. Waste suggestions. If you use array of size k instead of asset, then also it's 10 power 5 complexity, right? Doesn't make any sense. Why n? What is the maximum value that n can go for a given k? Okay, this should not be in the potential improvement. Should not be in the proofs also. It should be here. what is max n for a given k? Let's see with, for example, let's see with the scene example, take k equal to 9. Let's start with 1. 1 modulo is 1. 1 into 10 plus 1 is 11. So modulo 9 is 2. 2 into 10. This seems like 9 also doesn't end. Okay, let's see. 2 into 10 plus 1 equal to 21. 3. 31. 9. 3 are 27. 4. 41. 9. 4 are 36. 5. 7. 8. 9. 2, 3, 4, 5, 6, 7, 8, 9. And again it's repeating. Like when it comes 9 here, okay, my bad. Oh. What did happen? Yeah, after, okay, my bad, man. Okay, check it. After somewhere we get the 9, right? Because modulus will not get the 9. What is the maximum we can get? 1, 2, 3, 4, 5, 6, 7, 8. 8 is the maximum we can get. So 8 into 8 into 10 plus 1. 81. What? Do we get 8 or Chuma it is telling? Chuma I'm thinking 3 into 10 plus 1, 31, 4, 41, 5, 51, 6, okay, 61, 9, 6, 54, 7, 71, 8. Okay, got it. See, yeah, I can. So this is where I don't know whether the ID is from Google's anti-gravity, which they claim as the best agentic ID, but you see, it doesn't understand that 81 you have to do modulo 9 and answer is 0. It's just predicting the series like 2, 3, 4, 5, 6 आया, 7, 8, 9, 10 भी आएगा. Yeah, bloody reality. So here the output is 0. Okay, how many steps we did? 1, 2, 3, 4, 5, 6, 7, 8, 9 steps we did total. At 9th, we got answer. At 9th iteration, we got answer for k equal to 9. For 3, answer is 111, which is at 3. For k equal to 3. Okay, got it. The 5 answer is none here. Like, see again, like for 5, we have seen just now somewhere here. The answer is none, but still it is. I mean, like answer is -1. It's not none. So yeah, the conclusion is. Okay, conclusion. We, for a valid answer, guys, max n can go up to k. Since for 9 it went to 9, let's say inclusive, we can tell inclusive Okay, it's already auto typed. For invalid, it will be always invalid. For invalid, it will be anyway invalid. Does n value cross k num of digits? No, we have seen it. Doesn't go. At least I guess. I guess if the pattern that we saw is correct, the pattern that we seen above is correct. So yeah, let's implement this. Let's kick off this set. No need to kick off. Let's why to simply erase efforts. Effort should be visible, guys. Effort should be visible. So now this is not a while loop. So let's make it for loop. Parent. If we make the answer as answer equal to 1, answer less than equal to k, answer plus plus. Okay. Move all this. Okay. N equal to n into 10 plus 1. Modulo k. Okay. If somewhere if this n equal to 0, the we have to return the answer, and the why answer, because it's the length of number of ones, guys. Answer is indirectly the number of this thing. Return answer. How will you okay, here simply you can return -1. And it's not, is it okay? One more quick question here. Is it always guaranteed that answer will be only k? No. Answer is not only k. Maybe I'm not able to come up with numbers, but for definitely. So let's say if let's say some random number 47. So answer might not always be 47 once. It can be anything, right? Because beach may, what if this is divisible? I don't know whether this is divisible or not, but what if this is divisible? So that's why in that case, if this anyway in anyhow, if we reach this, if this we found this n as 0, we are returning that answer, and we are not going for next iterations, because the question says it's the smallest unit. So why is it? Okay, let's see, this should be good. Okay, let's run first. Oh, okay. K equal to 3, optus 2, accepted 1. Why is it like that? 0 length possible है ही नहीं. Okay, we started with 0. We have to start with 0. I think it should get accepted. Yes, if you see, earlier we were here, and now like we beat some good amount of people. And I'm always interested, what is the solutions, man? Who will come up with this? Uh, let's see why he beats everyone, because okay, okay. I think so. There are 70 test cases. This person would have seen identify that most of the invalid test -1 answer returning test cases are like 2 and 5. So that's why he is giving this. No, 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 not this. Okay. Mhm. Remainder one modular key is always 1 year. Why did he return this even this unnecessary steps? Yeah, somehow I don't know what is the intuition behind this. And here the reminder, but how did he break? We also did same thing here. How did he break? Okay, I think he might have definitely broken this because yeah, I think yeah, there is no breaking handling here. Because -1 written is this, and I don't know based on this how is it sure? K modulus 2. Uh, is it? Isn't it so obvious? Like okay, it's not and it's or okay. Or is it like any number that if two divides k perfectly, then if two divides k perfectly, then what? Y minus one k equal to 6. I yeah, I think I need to understand the logic behind this. How did someone like he or she come up with this? But yeah, I again it's a good question overall. So because yeah, how to come this? Because we observed many things. I think yeah, good questions yesterday and today. Yeah, and honestly, like if I'll be honest, if the see here, if you see, I guessed it. I guessed that this might happen. I guess that answer will be only less than k, and it's not only guess. It's I proved it here also. If k is 47, in middle you might have some number which are obviously less than k digits that modulus to 0. So initially guessed it, and yeah, I proved it. But if this wouldn't have happened, I think I would not have solved this question that efficient thing. I think this is efficient solution. Yeah, what's the time complexity? Do we need to discuss that? Yeah, I love time complexity. Time complexity is big of k. Space no need to discuss because we haven't done any space complex. We don't have any space things here. So yeah, that's what this. That's for the stream, and the main importance of this stream is not to focus on this DSA question. This I completely did myself. The main intention is to um, go with the search engines, and I'll paste the GitHub repo link of that the text file that in which I explained, and also Jupyter notebook. Yeah, 7:18. I'm already late to home. I'm ending the screen. See you next one.